Hey everyone, and welcome to Module 4. So this is the central nervous system. This is building on what we did last time in Module 3, which was all the cellular constituents to the central nervous system. So don't be afraid or don't hesitate to go back and review some of that stuff because it could be helpful, or it probably will be helpful for understanding the topics that we're looking at this time. In some ways, this is more complicated. In some ways, it's simpler than the last module, I find. It's simpler because we're looking at bigger structures, so it can be a bit easier to visualize instead of thinking about cells and ions and their potentials across the membrane. Now we're talking more about physical structures, but then in other ways, it's more difficult because we're building on it, right? So you really want to make sure prior to really taking this stuff on, that you have a thorough understanding of the previous module. Then it shouldn't be that bad. But again, here are the topics for this module. Topic 1 is emergent properties of neural networks and evolution of nervous systems. Okay, so this is how all the different parts that we looked at last week, or last module rather, come together to make a nervous system that is complicated and capable of, frankly, pretty incredible things. Topic number 2 is the anatomy of the central nervous system, the human central nervous system, obviously. Topic 3 is the spinal cord. Topic 4 is the brain. And topic 5 is brain function. All right? Now the learning objectives, or the specific learning objectives as part of this module, are 1. Explain and give examples of emergent properties of neural systems in humans and other organisms. So this is how all these neurons fit together to make either a circuit or something that's greater than the sum of its parts. That's kind of a lovely way, but sort of not super precise way of putting it, but you should be able to explain how all these pieces fit together to carry out a task or perform a function. You should be able to describe how nervous systems increase in complexity all the way along the scale, right? From very, very basic organisms like worms all the way up to, let's say, mammals or vertebrates. Okay? Describe how a hollow neural tube develops into the ventricles and 7 major divisions of the central nervous system. So this is a little bit of embryology. You should be able to define gray matter, white matter, tracts, and nuclei in the central nervous system. You should be able to describe the membranes that enclose the brain and the spinal cord, so all the protective layers that are outside of the central nervous system, like tissue itself, or rather, like proper. You should be able to explain the formation, distribution, and functions of cerebrospinal fluid. You should be able to describe the structure and functions of the blood-brain barrier. You should be able to explain how the following structures are organized in the spinal cord. This includes ascending and descending tracts, columns, dorsal root ganglia, dorsal and ventral horns, dorsal and ventral roots, propriospinal tracts, and spinal nerves. You should be able to name the major subdivisions of the cerebrum, the cerebellum, the diencephalon, and the brainstem, and you should be able to give their major functions. You should be able to name the 4 lobes of the cerebral cortex. This sort of falls into the previous point as well. And you should be able to explain roughly which sensory, motor, or association areas are associated with each lobe. You should be able to explain the behavioral state system and how it is related to the diffuse modulatory systems and the reticular activating system. This is getting into more basic functions, stuff that is really localized diffusely throughout the brain, often associated mostly with the brain stem. So this is really involving basic sort of functions that are essential for homeostasis. You should be able to describe the stages of sleep. You should be able to describe motivation and emotion and how they're related to brain function. You should be able to explain the role of the following in learning and memory. So short-term memory, memory traces, working memory, non-associative and associative learning, and habituation and sensitization. And then finally, you should be able to explain the roles of Wernicke's area, or Wernicke, and Broca's area in written and spoken language. Okay? So just like last time, this is all extremely interesting stuff. I hope you really enjoy it, and I look forward to reviewing this with you in tutorials.